We need to start this lesson with a definition. The definition of a relation. It is a set of ordered pairs. We call the domain the set of all the first coordinates, and the range is the set of all second coordinates. But more importantly, a relation is also a mapping. So if this is the set of the domain and this is the range, we can make different mappings, as when we're going to map Bob to the tie, Carly to the bow, Juan to the flower, and Bob also to the scarf. So we've made a mapping, and that is a traditional way of showing that. So we can look at the set of ordered pairs, and this is the relation, where the domain would be Bob, Carly, and Juan, because that would be the first coordinate. Notice you don't have to write Bob again. That would be redundant, but it would not be wrong if you wrote it again. The range would be the second element, and of course that's tie, bow, flower, and scarf. And notice we used everything in the range and everything in the domain. We didn't have to, that was just my choice. Let's look at this example. Can we make a relation? Sure, if this is the domain and this is the range, we can map any way you want. So we could match red with 3, we could match blue with 1, green with 2, you could also match green with 1, lots of different ways. Could you write that relation? We could do the set, and that brace is a set notation, and then we have the ordered pairs, and so we would have red matched with 3, blue matched with 1, green matched with 2, and I believe we'd also have green matched with 1 as well. And so then you could go through and name the domain and the range. The next definition that you need to know is the definition of a function. It's also a relation, but it's a special relation in that no two ordered pairs have the same first coordinate. So one example is listed here. Sally matches with pink, Carly blue, Adam green, Bob blue. So notice every first coordinate is different, and so we've listed the domain and the range. Let's go back to that first example. Would this be a function? The answer is no, because Bob is repeated. Would this example be a function? And again, the answer is no, because green is repeated. So you can kind of see in this mapping that you have kind of arrows going off of one thing. That makes it not a function, but it certainly is still a relation. Now, usually we don't talk about Sally and Bob's and ties and scarves. We have things in algebra looks like this. Now this is pretty scary. Notice, first of all, you have the braces. So that is the set. This is an ordered pair. And so the way you would read this is that A is the set such that the set of ordered pairs such that y equals 3x minus 5 and x are these numbers. And they ask us to find the domain and the range. Well, if you have a set of ordered pairs, in algebra, usually we have x and then y, that is the order. So the x's would be the domain and the set of y's would be the range. So notice they've told us what x is. So the domain is the set of the x values, listed in no particular order. So how could we find the range? The range are the y values, then we just need to plug in our x's, do some arithmetic, and get that y value, then the next one, and then the last one. So our range would be the set of the y values, and again listed in no particular order, -11, -5, and +4. Now here on this example, they've given you the x values. Sometimes we have to just assume what those x values are, and when they don't tell you what the x values are, you may assume them to be all real numbers, which kind of leads to this. If we had all real numbers, that would be an infinite amount. So what can we do if we have an infinite number of ordered pairs? We can't make a list like that, but we can draw a picture. Draw a picture of a line, y equals 2x minus 3. Now this is the equation. This line is a picture to represent all the solutions to that equation, meaning you can pick any point on that line, that ordered pair, plug them in for x and y, and that's going to satisfy that equation. Not just the pretty numbers that I'm kind of picking here, but all the numbers in between. So, and these arrows say it keeps going, so we could not possibly list them all. So how could I list the domain? I can't make an infinite list. You can't use dot dot dot. Well, if you pick all the x values, can you see any x values that this would not be? I mean, this would be what, 2, 3, this would be 4 something, and then we'd have 5 something, and keeps going up forever. Come down here. So we'd have a -1 for an x value, a -2 for an x value, and it would keep going. So this would be all real numbers. And we can write that in interval notation. Now the range is the y values, meaning we're finding out what are the y values, how far up and down this goes. Well, again, this would also be all real numbers. That picture, there's no value that y could not be. It's going up, 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 up. It's going down, 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 down. So again, an interval notation from negative infinity to positive infinity. How can we determine if a graph is a function? If you have no two ordered pairs have the same first coordinate, that leads to the vertical line test. Meaning, if you draw vertical lines through your graph, each vertical line should only touch the graph one time. And so this is a function. But if I draw a vertical line here, notice we have x is 1 mapped to 2, but x is 1 is also mapped to -2. This repeats the first ordered pair. It fails the vertical line test. So the vertical line test means if it passes through the graph more than one time, then this is not a function. So your job is going to be to look at pictures, look at graphs, and find out, do they represent a function? That's yes or no. And to find the domain and range and write that in interval notation. Right? So the easy part is going to be, does it represent a function? And of course you can just do one vertical line test. You could probably do that just in your head and say, no, this is not a function. But it still has a domain and range. Remember, that's still a relation, and a relation has a domain and range. So the domain, you want to go from left to right. So if you look at the x-axis, how far left does this graph go? Well, pretty much here. That's the leftist point that it goes. How far right? Don't stop there, because there's this part of the graph. I think it goes all the way out there. So what are those x values? Well, this looks like -6, and that looks like +5. So again, we're going to write that in interval notation. So from -6 to +5. Now the range, a little bit harder, because our brain wants to go from the top down to the bottom. But you've got to go from the bottom to the top, the negative numbers to the positive numbers. Right? So again, that's not the lowest point, but pretty much that is. So about the same, I guess. And that's at -5. And again, that's not the highest point. I think this is. And that looks, what, at about 3? And this looks like at -5. So we're going to go from -5 to +3, and this is not a function. So I think it's really good if you look at the graph and kind of say, how far left, how far right, how far down, how far up. Can you fit that function in a box? And that really helps you write that domain and range. So let's look at this next example. Is it a function? Does it pass the vertical line test? No matter where I draw a vertical line, it's only going to cross that graph one time. So yes, this is a function. What's the domain? You want to go from left to right. How far left does it go? From here, which is about a 1, to here, which is 7. So from 1 to 7. Now let me get a clear picture. Let's look at the range. All right, so again, we want to go from how low. This is the lowest point. This is the highest point, and we want to look at the y values because that's the range. What y value is here? From 0 up to 3. So yes, that is a function, and here's our domain and range. Now let's look at some more difficult examples. I'm going to call this number 1. Is that a function? No, it is not. Let's talk about the domain, the x values. How far left? So this is the leftmost endpoint. That looks at -5. But how far right? Well, that arrow and that arrow means it keeps going forever. So it goes from -5 to forever. We call that positive infinity. And of course, we use a parenthesis. Range. How low does it go? Does it stop there? I don't think so, because all these points are below that. How tall does it go? Does it stop there? No, because it keeps going. So if it keeps going down and it keeps going up and there's arrows, it means it keeps going forever. So down forever and up forever. So from negative infinity to positive infinity. In other words, all real numbers. Let's look at number 2. Is that a function? Yes, it is. It passes the vertical line test. Now we have the domain. Again, how far left? Well, I guess we're stuck at -5. And how far right? Do we stop here? No, because it keeps going. Even though it's going down, it's also going out to the right. So we go from -5 to infinity. So notice these have the same domain, but you certainly have a very different graph. Range, bottom to top. How low does it go? Well, I think it goes as low as it can go, from negative infinity. And how tall? Up there, that's the highest point. You want to look at the y value, which is at +6. Now we're going to get a little bit trickier. Let's look at number 3. Is that a function? Yes, it is. Now notice I have this open circle. Now that open circle means it gets really close to that value but just doesn't quite touch it, where this is an included circle. So when we talk about the domain, we still want to talk about left to right. So we from -3 to +3, but because this is an open circle, we're going to have -3 with a parenthesis, meaning really close but not touching, where the +3 is a bracket because it includes that point. Let's do the range from bottom to top. This is as low, this is as high, but this low point again is an open circle, and that value is at 4, and then it goes up to 6. So you really need to pay attention to those parentheses and brackets. And then this last one is kind of tricky. Well, first of all, it's just a line. In fact, it's a vertical line. So is it a function? Well, if I put a vertical line right on top of a vertical line, it touches it in lots of points. So this is definitely not a function. In fact, all vertical lines are not functions. Again, tricky. The domain. How far left, how far right? Not much. In fact, it only has one x value, which is 4. So we're just going to put that in brackets. That's the only x value. In fact, if you took any point on this line, this x value would be 4, 1, 4, 2, 4, 3, and so forth. But what about the range? How low does it go? How tall does it go? I think that's pretty obvious. It goes all real numbers. So take some time, go back over these examples, really try to understand domain and range from looking at a graph.